Welcome back everyone, and this is our second name reaction, but I prefer this name reaction as pretty much better than the previous one. You might agree with me. Okay, so Hoffman bromide degradation. The name itself is self-explanatory that Hoffman is the name, bromine is the bromine, which came brome, and amide is amide, and we have to degrade that amide in the reaction anyway, and that's it. That's all it. So let's see this reaction. So we have R, C, double bond O, NH2 plus Br2 because we are taking the bromine, of course. So this is amide. The DE word always brings the oxygen. Remember this. Now, Hoffman was very intelligent, so he used two things at a time, like Br2 and NaOH, strong base and bromine, not HBr, not RBr. He rejected these all things and chose Br2 because this is very advantageous when you see the reaction becomes that simple. Like in our case, we have RNH2 plus Na2CO3 plus 2 times NaBr plus 2 times, in this case we have H2O. I think I have balanced it correctly. You can check once more. Hydrogen is here. Okay, I have balanced it correctly. Well, you can write the reaction same way as I did once you have practiced enough. But for now, let's study this thing. Okay, let me remove the unnecessary parts from here that I have wrote. Okay, now we are done. So, what we are studying here? Well, that's pretty much interesting. We have here a reaction. So, what in the reaction we have? If you look closely, we are using three different reactants. This one is strong base. This is a halogen pair, which can be considered as negative in nature, and this is our amide. So this is our amide having oxygen, and our only intention is to remove this oxygen anyway. Okay, so what we have done here, if you look closely, there is a high probability of making the water out of it. So we have OH, and if we remove one hydrogen either from this side or just further consider if we take from this side, but the way we have written it, let's take it from this side. So it will going to form water. As I told you, water is very much stable, so it will going to form first. Now it's time for the Na. So we have Na and it will going to react with Br. So NaBr is the second thing. Remember our NaCl thing? NaCl is quite stable. As this is salt, so is the NaBr. It's stable either. But as you can see, the intention of adding the bromine Br2 is only so that we can have 2 Na in our hands left out. Why we want that? We want that because this oxygen that we are trying to remove will going to go with Na. Here it is Na2CO3, sodium carbonate, and that might be familiar to washing soda if I add 10H2O also. So this is very helpful for us. Now whatever we have left with is R and NH2, and surely this C has gone along with Na. So we are left with our final product, which is 1 degree amine. So the reaction is simple, logical, and easy to grasp. So let me ask you a question here. Why the previous reaction was so complex? Hmm. Let me show you its glimpse again. This was the thing that we have just studied. Can you believe it? So, and this one is. So why it is so? Well, in the Gabriel Pethelmite synthesis, we have used the benzene, and you can see so many bonds here. So there is a high probability of resonance. And when there is high probability of resonance and the structure is quite disturbed and that big and that complex, you cannot go for the simple things like we just studied. So that's why the reaction is complex. So you must respect this person. So my salute goes to this person because he actually did it and we are studying it. Okay, so I want to mention one thing here that Pethelmide on treatment with ethanolike potassium hydroxide forms a potassium salt. Potassium salt means Kx that we have studied. So what's new in that? Well, the new thing is aromatic primary amines cannot be prepared by this method. Yes, aromatic amines can't be prepared or cannot be prepared by this method. Prepared by this method. So this is the limitation of Gabriel Pethelmade synthesis. But I told you that why we are using it. Because of its complexity, the things are not that simple as we have studied. We have studied in a fun way so that you will not feel that it's impossible to learn. Well, this is Hoffman bromide degradation, and I have a good news for you that this is our last name reaction. After this, all the reaction that is on our way is quite logical, and I promise that nothing is going to be that big as Gabriel Pethelmade synthesis. So stick with me, stay tuned. God bless for learning more.